So this is Gene Bohensky from IR Thermal Systems, and the title of this presentation is Choosing the Right IR Heating Products for Your Process. And we're going to talk about IR Thermal's experience deploying infrared heating technology. We have some specialists also in the audience that will help us out when I call on them. But basically, we're going to be sharing our experience deploying infrared heating technology, and we'll also give you some exciting news of some new products that we have available that we've developed. So let's start by just talking a little bit about our company. IR Thermal Systems was founded in 2020 after the former management team purchased the assets and intellectual property of Radiant Energy Systems and Anderson Thermal Devices. So our core team and employees have experience since 1985. This year we purchased Therma-Tech heaters, and that expanded our infrared heating panel and compact heater product line. And then we're going to talk a little bit more about that in this presentation. Our core competence is the design and manufacture of custom engineered process heating solutions for improving performance and lowering production costs. We focus on quality and dependability, and we also constantly invest in the latest manufacturing technology. We produce our own high-quality component parts. To the right there, you can see our stamped foil heater elements. That's something we produce in-house, and we're proud of that. We are focused on continuous heating processes. And technology independence allows us the freedom to choose the best for the customer's application because we don't just focus on infrared, we also do hot air heater systems as well. So how we help? We build custom process heating solutions, preheating, drying, and curing applications, hot air systems, IR systems and heaters, combination hybrid IR and hot air systems, where we use IR as a booster. With infrared, we increase line speeds, reduce energy costs, and save space. We can level out uneven temperature or moisture across a web, and we can heat selected zones across a web. And it is made easier, and we have a wider range of products available now that we have the complete Therma-Tech product line of panel heaters of different sizes where we can put those heaters where they're needed in your process. So we serve a wide range of industries, converting, paper, film, and foil, printing, nonwovens, plastic, adhesive lamination, batteries, medical devices, filter media, fiberglass, advanced composites, industrial fabrics, automotive, packaging, wire and cable, textiles, and many other industries. So our three major applications for continuous processes that includes drying, the solvent vaporation and evaporation, curing, where a final web or coating temperature requirement, normally following a drying requirement, where like modern paints and powder coating. We also have heating, raising the temperature of a product, do application where we require heat set, heat before lamination, or 100% solids applications like silicone coating or foils, and also metals. So why choose IR heating? Well, infrared heating systems are more efficient with lower energy requirements for the same results. So the energy costs, the savings can be significant, and more companies are installing this technology to be more green. So energy is directly transferred from the heater to the target object for a higher heat transfer rate, and they're available in electric or gas powered. So general infrared heater characteristics. The heaters are easy to zone for uniform heating of the product and width changes, fast response to changing process conditions, including quick startup and shutdown in most styles of heaters, lower initial capital and installation cost, including floor space savings, and often added to existing conventional dryers and ovens to increase line speed and improve process quality. So there's a wide range of different wavelengths available, from short wave to long wave with medium in between. The heating temperature is dependent on the wavelength. The wavelength used for industrial infrared heating applications ranges from 1.17 micron, that equates to 4,000 degrees Fahrenheit, to 5.4 micron, 500 degrees Fahrenheit. So short wave emitters, those are typically lamps. They go from 2150 to 4,000 Fahrenheit. Medium wave emitters, 900 to 2150, and long wave emitters from 500 degrees and 900 degrees. You select the wavelength based upon what you need in your process. That's where we can help you on the application side. In general, you would say that medium wave heats more of the surface and short wave can penetrate deeper into the product for heating. So you choose wavelength based on the application. You can see some of the absorption factors of the different materials. On the left, you have water film thickness at 10 micron. You have your absorption factor there at 3, and the peaks at 3 and 6 micron. And PVC sheet thickness at 1 millimeter has somewhat different peaks, so where you could adjust or you require the heating elements that are adjusted for and the wavelength adjusted for your application. Here we have a video, came in right away. Here's our technical expert, Cornell, demonstrating a medium wave, one of our SFA products. And I'll play that video. This is in our lab where we have this turned on. He'll explain a little bit about the technology here.
Today we're demonstrating our medium wave infrared heater. This heater is used for typically for heating webs, heating plastics. It is in the 3 to 8 micron range. That is an ideal range for absorbing water. We make everything here. This heater, we make the elements, we pin them on the boards. Some boards have holes in them for airflow through the heater to aid in the heating process and break up the vapor barrier. These heaters can be sold individually to our customers or incorporated into an oven system complete with framework, doors, controls. They can be controlled by thermocouples internally in the heater or by infrared thermometers measuring the temperature of the material moving under the heater. Generally, these are 2 to 3 inches away from the product, which can be horizontal or vertical, any direction. They are known for fast heat up and cool down. And we'll demonstrate real quickly. If you could please turn on the heaters. We're going to bring this up to full power. Usually it takes less than a minute. It depends on the element we use. The thicker elements are a little slower. Thinner elements are a little faster. This particular unit is a rental unit that we can send to our customers to try on their own line. As you can see, the elements are similar to the elements on your toaster oven. It's the same wavelength. So if we shut it off now, you'll see how quickly it cools down. And in addition to that, if we had air blowing on it, we could increase the velocity of the air to help in cooling down the material underneath the heater so that it doesn't get damaged.
Next up is the shortwave heater that we're going to demonstrate. This is one of our heater cassette style or closure style with lamps that we produce. And this will show you a little bit of a difference with the way shortwave works with a lamp assembly.
Now we're going to demonstrate the shortwave infrared heater. It's in the 1.5 to 3 micron range. It's a quite intense heat in a small package. This particular unit has some air holes for aiding in the heating process, breaking up a vapor barrier. And the lamp itself is made of tungsten inside with a gas that's in a sealed quartz tube. These elements can get up to 3,500 degrees versus 1,800 degrees on the medium wave. So now we'll go ahead and turn it up, and we'll bring it up slowly because it does have a high inrush. So if you're using an SCR like we are, you want to make sure you have a little bit of a delay so that you don't blow fuses. We use high-speed fuses on the SCRs to protect them. So here you can see it sits in the just maybe a quarter of the way, halfway, and it will get very intense, the heat. It is okay to look near it, at it, but not directly at it, just like you would look at the sun. It's not as hazardous as UV lamps are. UV lamps you don't want to look at all. You can look at these. best not to look at them for an extended amount of time. Shut that off now. As you can see, it's an intense amount of heat in a very small area. Quick heat up and cool down. Thing about these is that you can't control them with a thermocouple internal because the lamps are sealed. The best way to do it is with an infrared thermometer measuring the temperature of the material being heated.
So next up are infrared heaters. We have gas versus electric that we'll talk about now. So the electric heaters have a wide temperature range with better turn down, with infinite temperature control and tunability. They operate, they're specified in a range of 10 to 55 watts per square inch. So gas infrared heaters, the difference is that there's a higher density of heat that allows higher temperatures and high intensity heat in a small package. So that's up to 50K BTU per square foot or 60 to 100 watts per square inch. So as I said, more intensive medium wave heating. The choice of gas or electric might be made by local energy costs. A lot of times, your local energy costs and the comparison will decide what you're going to do in that plant. And they're often used to cure powder coatings on any substrate. So next up are really to explain a little bit more about our product lines. We offer what we call the SF and SFA stamp foil and stamp foil with air heaters. This is a full product line of modular panel heaters and heater modules. They can be used as booster heaters and strategically placed in existing processes. So optional face materials make heaters suitable for food applications or corrosive environments, and they're manufactured by IR Thermal with proprietary heating elements. And here's a little bit about our new Therma-Tech heaters. It's a line of smaller heaters designed also to be put into larger processes with the same type of different face materials. And I have Kurt Leach here on the line. I'd like to have him talk about how these are placed in certain processes and can improve the performance of existing dryer processes. Kurt, are you there?
Okay, can you hear me?
Yes.
All right, let's see if you can. Yeah, there we go. Sorry about that. Yeah, a lot of machine builders, they have equipment that is quite compact, and this line of heaters here is designed extremely in mind of being able to fit a lot of energy into a very small space. The range of applications is really up to the imagination. Anything from shrinking shrink tubing on conductors on a continuous fashion to there are food applications that we get involved with also. So this is an ideal design, and we can meet any of the specifications because we build everything right in-house. We don't depend on outsourcing of anything for this product line. Now, the other when we talk about some of the other infrared applications, the important thing is to determine what you are trying to do. Are you trying, as Gene pointed out, we are either trying to dry something, we are trying to perhaps cross-link it or cure it by taking it up to a certain temperature to allow the catalytic effect of the chemistry of the coating to cross-link, or we are trying to just merely heat it so that it can be formed, such as thermal forming or pre-lamination, or in occasion, sometimes we get involved with metals where we are being asked to heat them up so they can be press fit into a piece of equipment. This is not an uncommon application either. Does that cover what you wanted, Gene?
Yeah, absolutely. And one of the things I wanted to point out that's unique about this product line is our ability to make these in pretty small form factors. And that allows us to install them in existing processes, and it gives us the flexibility of really being able to improve the existing processes by strategically putting these heaters in areas where they'll fit and have the ability to improve the temperature, consistency, and the quality of the product. That's one of our strengths. You can contact us with your application on that end, and we can help you out with that. One of the things we also do, these type of custom heater cassettes with different lamps in them. And we build those too also for different applications. And we have done many versions, but again, it's based upon the temperature requirement and what is needed by the customer. So I just want to go over in general some of the infrared heater applications that we have worked on with infrared. And we've seen them used for industrial drying, powder coating and paints, coating, annealing, filter media, nanofilms, battery, and fuel cell materials. Today, as solvent chemistries become more complex, infrared heating becomes required due to the faster response time and better control of temperature. Also, plastic for embossing, medium wave infrared directly heats and softens the surface quickly. Also for water-based coatings on film, medium wave infrared directly heats the surface and is the most efficient wavelength for water evaporation. And it can be used with or without air. Air removes the steam and prevents the skinning effect, improves efficiency of infrared to remove volume solvents. Here in the next slide, infrared is also used for adhesives, impregnated fiberglass, and food applications. It's also used to improve paint quality. New coating methods require consistent high heat for proper curing. Metal processing, infrared emitters can be precisely adjusted to the product and process. So medium wave IR dries faster on the surface, while short wave IR tends to penetrate deeper. High gloss metals reflect very strongly, while dark surfaces absorb the heat well, and each metal absorbs heat differently. Flat sheets or solid blocks heat up at different rates. And in general, infrared improves the energy efficiency of drying applications. So getting to know IR heating, if you're not familiar with IR heating, it's essential to run trials in a lab or on a pilot line to confirm dryer sizing and the desired finished product. We found some coatings may not be able to take advantage of the higher rates of heat transfer and may skin and blister, may be difficult to work with temperature-sensitive substrates. And since infrared is basically a surface phenomenon, sometimes it's harder to dry heavier coatings without overheating the surface. We have a rental program that allows customers to deploy infrared at a low cost to learn. It's one of the things that that'll help a lot of our customers. So let's look at some applications. Here's shortwave infrared for drying coatings on metal webs. Here we've put lamps in this large assembly here. We have a multi-zone infrared system for automotive interiors shown here in this picture. Here is a multi-zone IR preheater for embossing wall coverings, and this is a great example of one of our smaller panel heaters. You can see on the right how they're installed in the system. It's a great way to use our products. Here's a high-intensity infrared gloss recovery system for film. Again, we've built this enclosure for the lamps to produce the desired effect. And here's an infrared oven laminating web to web using film, powder, or other adhesives. That's another large piece of equipment. That's an entire IR heating system that we've built. So let's talk one last subject is the combination and our hybrid heaters, where we combine different types of heating methods. And we do two different types. We can do combination convection and infrared, and even combination electric and gas infrared. But in many cases, the infrared section is used as a booster to existing processes. And we have a lot of experience here doing this, helping customers improve their existing processes. That allows faster warm-up of the web in the process, increases the line speed of existing processes, expands the production capacity of existing equipment in the same footprint, and can improve overall process temperature consistency. It's often been used to solve specific customer quality problems. So we've had two larger problems we've solved. One at a customer that was annealing plastic bottles. We strategically placed infrared heaters to eliminate cracks during bottle handling. In another application, we preheated heavy commercial vinyl wallpaper. Infrared heaters were added to evenly heat the paper across the entire surface, greatly improving embossing quality. And here's a couple of examples of some equipment we've built. Here's an infrared hot air impingement combo dryer with the infrared preheating. And here's another example with an infrared and hot air dryer combination for drying water-based PSA on PE film. So we'll round out this presentation to talk about our rental heater program. You can see we have controls and a heating element. We can provide with a very fast lead time. This is really a benefit where we can provide a package that includes the heater, blower, and controls. It's designed for a quick trial setup. It's plug and play with rental terms as short as 1 week are available, and test units are available for running trials in your facility on your line. So at this point, we've concluded our presentation and we've come to our question and answer section. We have a number of people in that are participating. Just wondering if anyone has any questions. We have some experts on the line. Do you have an application that you're working on that you'd like to get some help with?
Hi, this is Mike. I work at a energy consulting firm, and we frequently go into sites and try to help them find things. But we've seen a lot of people recently wanting to electrify natural gas processes with infrared for heating, and I just wondered if you've seen a business increase because of people wanting to control their natural gas emissions, and what areas you may be seeing that in. People using IR more rather than natural gas convection based on the greenhouse gas emissions. Is that a factor in your business at all?
I'd like to address that, and if someone else would like to also, we have absolutely seen an uptick in all types of natural gas replacement in terms of whether or not it was a steam boiler or a direct fired gas heater for a convection process. We would look at the application carefully and determine what would it take to convert or to supplement those systems utilizing an electric infrared device. Now, if some convection, no matter what you do, would be required, we have even also been involved with converting direct fired hot air gas systems with convective electrically heated systems. So there is a desire to minimize that carbon footprint. It's a matter of, can we do it and have them save some money on energy because of the efficiency? Natural gas system, if it's just hot air, you're lucky to hit 50 or 40 or 50% total overall system efficiency. With a well-designed infrared system, it is possible to get up to 70% and above. And in doing so, depending on how many kW or BTUs per hour are connected, this can add up. So hope that answers your question.
Yeah, thank you. Thank you very much. Appreciate it.
So I want to thank you guys for the presentation. I am a consultant. I have various customers who occasionally ask for help in upgrading their system, and I do recommend you guys. You're one of I try to not play too many favorites, but I also try to I try to recommend people I feel confident in, and not people that I need to worry about my liability insurance rates going up. So you're one of the companies I recommend. My question is, in the a couple of slides back, you showed an array of like 6 different heating devices, and you talked about a couple of them in this presentation. Are these all things that you make, or what are the half a dozen panels in that slide?
That slide is rather interesting, and it brought your interest, so I guess it served its purpose. We use that at trade shows to show that you can combine. What we had there was we had a shortwave lamp next to a fast response medium wave lamp or emitter next to a standard medium wave emitter. And then next to that were a couple of our stamped foil type heaters with and without a glass cover. And Ted, if you want to reach out to us by email, I would be glad to send you specifics on that. Now, all of that was in, if you look, there were slots,
Right.
air nozzles between them so that you could combine that with hot air, you know,
Well,
or
or even
ambient
room
air.
temperature or something. You got to get the water out somehow.
Correct.
It's all-
And not only that, once you get the water up to boiling temperature, you've got to break that vapor barrier to carry it away.
Yeah.
Otherwise, it'll just sit there and possibly recondense back onto the web, and that's a really not a good situation. But good point. We've attracted a lot of attention. It's I hate to say it, but whether that particular device would that ever be used in the real world, I would say no, not because it has way too many.
That's probably not the optimal configuration for anything. no.
Correct. But certainly any two of them could be utilized for whatever reason.
Yeah,
We have
real world, we would only use one of those heaters in between the nozzles, but we have done that before.
yeah, right.
No, I think that's a fantastic demo. I like that. I also like the fact, I mean, it starts with the name of the company, that there are a lot of people that want to sell IR, which is fine. There are people who sell hot air dryers, but you guys are pretty open about, you know, do you need hot air? Do you need IR? Do you need a hybrid? I find that every product has its, you know, it's like you put things in the oven. Do you want to bake it or do you want to broil it? Well, you know, you get a whole lot nicer crust on things if you broil it, but, you know, if you're making bread, you probably want to bake it. You know, it's
Very true.
Yeah, it's like these barbecue grills now. You see, they actually put strips of infrared heaters in the cover of the barbecue grill to get that crispness on the steak. I
Yeah,
don't know if you've seen that or not, but that's a good
I
example.
haven't. I haven't.
Yeah, yeah.
And are you familiar with a sous vide cooking that they use in restaurants?
No, this is like a for consumers.
No, but so you can buy a sous vide. I have a sous vide for my wife. So it's a constant temperature water bath, and so you put something like a filet mignon in there, and you put it at like 115 degrees, and so that entire piece of steak will be medium rare,
Mm.
including the surface. And then,
Wow.
and so that's what they do in the restaurants. Is they have these big baths full of steaks at different temperatures, and when you order medium well or whatever, they pull it out of the right bath, and they take and they put it on the grill and just go to sear the surface of it,
Ah,
and then you serve it, and the whole steak is perfect, but it's got a nice crisp on.
ah.
IR would be even better. You just take the damn thing, you just put it under an IR, you get a perfect. You probably get a much better crust. That way.
Yeah, yeah. These are barbecues for, propane barbecues for home use, and they have in the cover, they have little infrared heaters. In addition to cooking it with the heat from the propane coming up, this is like putting a little char on it with the infrared.
Yeah, uh, my grill is not that fancy, but Father's Day is coming up.
Neither is mine, but I've seen them.
Yeah. Thanks. I really appreciate it, guys.
Thank
Nice
you.
presentation.
Yeah, thank you. Does anyone else want to talk a little bit about Therma-Tech products? Kurt or Cornell?
No, I think you pretty much covered it. It's that small heater where you got to get into a small area where, our standard heaters are usually built for web applications and larger materials. The Therma-Tech heaters is a niche product that will be able to be used in small areas and small angles where you couldn't get in with a big heater. You could get in with multiple small heaters.
Exactly. If you have an existing oven and you have no room that you want to run faster, you're running at 100 feet a minute, you want to go, I don't know, 150 feet a minute or even 200 feet a minute, it is possible to utilize these small, low profile. We have some that are 2 inches by 2.5 inches, and they can be up to 100 inches wide, where you can fit it almost anywhere, nooks and crannies, like Cornell said, and it would allow you to apply some energy to boost that web up, even to give it more energy into the web to allow it to run at a higher line speed. So they're extremely effective in that use for making boosters.